Hello. Okay, you should see the desktop. Should hear me. Let's see. There is it. Can you hear me by now? Let's see. The chat up. Okay. Sorry, I'm sorry I'm late. I lost track of time. I was writing something and I lost track of what time it was. Okay. Okay. Um, okay, we're going to continue talking about arrays today. And first, let me say, I'm almost done with grading exam one. I've got about another hour of grading to do. So you should see your exams one scores either later this afternoon or this evening, because I don't have that much left to do. I'm almost done with them. So look for your exam one scores today. And like I said before, be sure you look at the exam itself, because that's where all the notes are. That's where you can see what score you got for each how many points you got for each problem, and you can see any notes or any corrections that were made. So please make sure you look at the exams themselves. Okay, and also those exams are good for you when you study for the final exam. At the end of the semester, there'll be a final exam, and seeing how you did on these problems, make sure that you understand how we're supposed to do every one of the problems on these exams is a good step towards preparing for the final exam. So make sure you download, you look at your exam, that's your graded exam. Okay. Um, okay. Um, Now, where we left off is we're actually doing this section 7.2, traversing an array. Now, there's a lot we're going to just do a lot of examples of traversing array. Okay, so we're just going to keep looking at examples of traversing an array. And we're also going to do one other thing today that's actually not really in either of the textbooks, and that's the interaction between arrays and methods, which is really important. So we're going to look at today at examples of how methods and arrays interact. It's kind of hinted at in both of the books, but we're going to do a more direct look at arrays and methods. Okay, so let's look at an example. Open Dr. Java. Hmm. Okay. Um, let's see. Actually, we did that one last week. Let's see. Let's look. See. Um, hmm. There. Okay. Okay. So we did this count occurrences. Oh. Okay. So here's our basic iterate through an array. Traverse. We use two different words. We use the word traverse an array or iterate through an array. So we'll commonly see two different ways of talking about stepping. The simple language would be stepping through an array from the beginning of the array to the end of the array. But you got to be a little bit careful. Remember, arrays start counting at 0. So the last item in the array is not the length index. There is no length index. It's length minus 1. So we use a strictly less than here. Okay. I mean, if we wanted to, we could do it from 1. No, actually, we can't do it from 1. We could do it from less than or equal to length minus 1. We could do less than or equal to length minus 1, but almost nobody ever writes it that way. Okay, so this is what a for loop looks like. Almost all the time when you want to go from beginning to end of array, you almost always write it like this. Index I equals 0, start at 0. That's the first item in the array. up to but not including the length of the array, because since the array starts counting as 0, the length of the array, that index is off the edge of the array. Okay, then you can do anything you want inside the loop, but this is the for loop for traversing an array. Okay, now let's look at, we just did count occurrences. Oops. Okay, here's a simple example of what you might do when you go through an array. Let's find the largest number and the smallest number in the array. Okay, so this is a real common problem. Find the max or the min, or find the largest or smallest number in an array. Okay? So what we're going to do is create an array of random numbers. Okay, so that we can run the program, and every time we run it, we get slightly different results. So that makes it a little bit more interesting. So let's create an array of, I'm going to make it much shorter so that we can see the whole array. So it said here 100, just make it 10. Okay, so I'll change it to 10 so that we can, if we put it on the visualizer, we can see the whole array. Okay, now this is going to create an array of 10 numbers. Okay, then we're going to now that creates the array. This creates a name for the array. Remember, this line does 3 things, and we're going to keep emphasizing that, it's one thing we'll always keep reminding ourselves that this does 3 things. It creates the object, which is an array. That's in the picture, that's over on the right-hand side under objects. It creates the reference variable, okay? That's inside of main, okay? And then it points the reference variable at the object, okay? Now the array has got 10 ints in it, and since we didn't give them specific values, they're all zeros. So we have an array of 10 zeros, okay? Then we create this thing called the random number generator, which is a thing that will essentially let us roll a die. Here's a traversal of the array from the beginning to the end. Okay, and we fill the array with random numbers between 1 and 500. Okay, so we're going to get 10 random numbers between 1 and 500. In fact, let's just work with small numbers for a while. So that's a random, that's 10 random numbers between 1 and 5. So that's rolling a 5-sided die. Okay. Okay. Now let's find the large. Actually, if we run, if we're gonna roll a die 5 times, if we're gonna roll a 5-sided die 10 times, we know what the largest number is going to be. It's almost always going to be 5, and the smallest number is almost always going to be 1. So let's make it 50. So we really don't know what the largest number is going to be. We're going to roll a 50-sided die 10 times. Who knows what the largest number might be? It might be something close to 50. It might not. It might even be 50. There's a small chance that it's actually 50. Okay? So we'll roll a 50-sided die 10 times and see what the smallest number and the largest number is. Okay. So this puts random numbers in the array. 10 random numbers between 1 and 50. Okay. Now we want to find the maximum number and the smallest number. So here's what we do. We start off with guessing that the largest number is the first number in the array, and the smallest number is the first number in the array. Okay. Now, that's possible. Yeah, if the same number is in the array 10 times, then that same number is both the smallest number and the largest number. But the way we think of this is we just think that we're making a guess. We're taking the first number of the array and thinking, well, it might be the largest, it might be the smallest, so we make that guess. Then we're going to go through the array, and actually, I could fix this. I don't have to start at 0 now. I can start at 1, because I've actually already looked at the 0th entry in the array. Okay, I've already said that my guess is the 0th entry. So now I'm going to traverse the array starting at the element 1, which is really the second element in the array. And what I'm going to do is look at that element. Is it bigger than our guess so far? If that number is bigger than our guess, we replace our guess with that number. We update the guess. Okay. Then we take that number that we're looking at and we compare it to the smallest number. If it's smaller than the smallest number, if it's smaller than our guess so far, we update our guess to be that number there. Okay, so this is a simple example of how you would step through the array and do something by looking at every element in the array. You look at every element in the array, Here's where we look at the element in the array. We do something with it. We compare it to what our guess so far is of the largest number. And then if it looks like this number is a better guess, we update our guess with that number. So here we're reading a number out of the array. Here, and again, here we're reading a number out of the array. So we read it out of the array to compare it to here. Then we read it out of the array to update our guess. In a little while, we'll see examples where we might write something into an array. Like notice right now, we're traversing the array and reading the numbers in it, which is actually the more common thing. A lot of times when you have data, a lot of data, you just read it. You read the data to find out something about it. Occasionally you read data and modify it, but it's much more common to read data and ask questions about it. What's the largest? What's the smallest? How many times does a number appear? Is there a certain number that we're looking for in the array? How many times does the number appear in the array? All those are examples of reading the numbers in the array and not updating it. The most famous example of where we'll see of where you would update an array is if you're told to take the numbers in the array and put them in numerical order to what we call sort the array. So I might give you an array and say, okay, now put the numbers in the right order. Okay, that would be an example where you may have to move things around in the array. But right now, a lot of these simple things are just going to be reading the array, just reading numbers out of the array and then doing something with them. Okay, all right. Let's actually put this on the Java visualizer because we can see it better. It's small enough. When I made the numbers, I think, let's see, yeah, with an array of just 10, like 10 random numbers between 1 and 50 is going to be small enough to fit in the Java visualizer. Remember we saw last week, the Java visualizer is a little bit picky about how big a program can be. Okay, this is a complete program, so I can just replace what's there. Okay, I need to import this random number generator. So if I want to be able to generate random numbers, I have to import that. And then everything else is pretty much straightforward. So let's visualize it. Okay. Okay, so start with this line here. It does the three things, and we'll see the three things over here. Notice that it really is three things. If you think about it, what we've done is create this yellow thing, that's 1, create this blue thing, that's 2, and create this arrow, that's 3. Okay, so that was the right-hand side creates the thing on the right-hand side, the array. The left-hand side creates the variable on the left-hand side. Well, actually, I'm up here. Yeah, we just did this line. The right-hand side creates the right-hand side, which is the array. The left-hand side creates the left-hand side over here, which is the variable. And the equal sign is the thing that says, make this one point at that one. So the equal sign in the middle creates the pointer in the middle there. Okay, then we're going to do the same thing here. We're going to create a random, this object called a random number generator. And we're going to create a variable we call random. And then we make our variable point at the object. Okay, so we don't really know what's inside that. We know what's inside an array. An array is a bunch of numbers, and the visualizer is going to show us what's inside that object. We don't really care what's inside of a random number generator. So the Java visualizer doesn't even pretend to show us what's inside of it, and we don't really care. But there's data inside there, and there's methods inside there. It's a regular object. There's a lot inside of it, but we don't need to care about what's inside that object. So we have the variable pointing at the object. Okay, and again, always keep reminding yourself that's three things: create the object, create the variable, make the variable point at the object. Okay, now we can start our loop. Right now we're right here. We're on line 13, but we're right here. We're about to create the loop variable. Okay, so now I'm right here. I've created the loop variable, and I need to check now. Remember, this order is initialize, test, do what's inside the body, then increment, then test, then do what's inside. Okay, so now I'm checking, is I less than the length of the array? Okay, and the array's length is 10. So it goes from, the indices go from 0 to 9, and the visualizer is doing this kind of weird editing out the zeros. The fact that there's all zeros from here to here, so it kind of edited some out and you don't see all the zeros, but there's 10 slots in that array, okay? So right now, 0 is less than 10. So we go inside the body of the loop, and now we're going to create a random number, which is, remember, this thing generates a random number between 0 and 49 inclusive. It generates, when you say random next int 50, because it's so ingrained in the Java language to start counting at 0, that notice that this thing kind of acts like a little bit like an array. It starts counting at 0. So the random numbers it generates are from 0 to 49. So then we add 1 to them to shift them to between 1 and 50. We could leave them 0 to 49, but I thought maybe it'd be better to make them 1 through 50. Okay, so you could either leave them 0 through 49 or shift them up 1 and make them random numbers between 1 and 50. You go to the store and nobody sells you die with, I don't think anybody sells dies with a face with 0 on it. I don't know, maybe people who play games more. Has anybody ever seen a die with a 0 face? Does any game use a die with a 0 on one of the faces? Does anybody know?
A D10 for D&D.
Pardon me?
A D10 for D&D. The 10 is represented by a 0.
Oh, so that's cheating. Yeah, so they, instead of writing out 1 0, but the 0 means the last number, not the first number then, right?
It can be used for either because 2 D10s make up a %.
Okay. Well, then, okay, then maybe they're being clever. Yeah. So yeah, here we think of 0 as the first. So we count from 0 to, this is 10 array indices. We count them from 0 to 9. Okay. And the random number generator kind of is modeled on this idea. If you want 10 random numbers, they're going to be between 0 and 9, not between 1 and 10. Okay. So we'll go ahead and add 1 to make them random numbers between 1 and 50. Okay, so let's get our first. Oh, cool. Yeah, somebody's showing, yeah, the video. Is that, everyone can see that? So that's, how many sides are on that die? Is that a 10-sided?
This is a 10-sided dice.
Yeah, with a 0. So you can think of it as 0 as, is the highest number then 9? Is there an actual 9? Yeah, so you can think of it as an array, or you could think of it as 1 through 10, or you could think of it as 0 through 9. Well, that's okay. So they do it that way. Some people do it that way. So in that case, you could either think of it 2 different ways: 0 through 9 or 1 through 10. Okay, so Java has really got itself ingrained with the idea of you start counting with 0. So that shows up even here. The 50 a random number with a 50 there is not 1 through 50, it's 0 through 49. Okay, so let's generate our first random number. Okay, 23. Okay, now we are going to go, now we just generated the random number. Now we're right here. So we're going to increment I. So I goes 1. Now we're right here. We have to do a test. We do the test. It succeeded. So now we generate our second random number, 23. Wow, that's actually a little bit weird. You know, we got the, it's out of 50 numbers, it's getting less and less likely that as you make this number bigger, it's less and less likely to get a repeat of a number, but we did get a repeat of a number, okay? And then we'll just step through here and fill up the whole array. Let's see. I can expand the screen, so it'll be eventually it's see all the array. Okay, there's the last one. Now see where we are. We're on this line here. I is 10. We just did the increment here. Okay, so we're up here and we're doing the increment. I is 10. 10 is not strictly less than 10. So we've finished the loop, and you can see we've filled up the whole array. So now we're done with filling the array. So we've done the filling of the array job. Okay, we see our 10 random numbers. Okay. And then now we're going to make 23 as our guess. We're going to guess it's the largest, and we're going to guess that it's the smallest. So we create our 2 guesses. Okay, so our 2 guesses are that number there. Okay, now we're going to start going through the array, starting at the item 1. Since we've read that item into the guesses, we don't need to compare it to the guesses. So we'll start with this number here. Okay. All right. So now we create our index variable again. So we just created that I again. Now that I is not quite really the same I as this I. This I lived in that loop. This I is a different I living in that loop. So this I disappeared when that loop was done. And now we can use I again. It's really a different I. We use I again, and we started at 1 this time instead of starting at 0. And then we have to check. Now, next, we're going to check it. Okay, that was true, so we're down here. Now we're going to read item 1 and ask, is it strictly bigger than the largest? Notice that we want a strictly larger here. Actually, it's kind of convenient here. This number is the same as that number. But being the same, there's no reason to update our guess. If this number is the same as our guess, we don't really need to update guess. So the thing here is the number we're reading actually strictly bigger than our guess so far? If that's the case, then we update. So that's not going to be true. So we don't do an update there. And then here, same. It's going to be, is that number strictly smaller? Okay, there's no reason to put an equal sign here because if they're the same number, if the guess here is equal to the number here, there's no need to update. Okay, so we're looking for strictly smaller. That's not the case. Okay, so we skipped over the updates, and we're now going to increment to the second item in the list. So now we're going to be looking at this guy. Notice that this guy will make us update our smaller number. We should see our smaller number update now. Okay, so is it larger than our largest number? Is it larger than our guess so far? The answer is no. And now here, is it smaller than our guess at what the smallest number is? And the answer is yes. So now we're going to update this guess to be 12. Okay. And if we look ahead, we see that that actually is the smallest number. Now, the loop doesn't know that because the loop won't know that till it gets to the very end. But we know now that we've actually found the smallest number. We haven't found the largest number yet, but we have found the smallest number. Okay, so now we go over to 3. Okay, we just did the increment. Now we're going to do the test. We're still inside the loop. 3 is much less than the length of the loop. Okay, now we're at 35. Is 35 is 35 larger than our guess so far? And the answer is yes. It's not the largest number in the array, notice. This is not the largest number in the array, but it is the largest number we've seen so far. Okay, so it's time to update largest. We're going to make 35 our guess as that's the largest so far. So we're going to make 35 our current guess. Okay, and then we don't need to update the smallest. Okay, now go to the next item, 4. Okay, item 4 is 33. Okay, 33 is not larger than our guess here, and it's not smaller than our guess here. So we're going to skip both the updates. Okay, look at item 5. Okay, item 5. We see that item 5 is going to update our largest now. Item 5 is bigger than this one. Okay, so we go 45 is greater than 35. Or I'm sorry, 46 is greater than 35. So we're going to do an update of largest. So this is going to get updated now. Okay, so we got 46. Now notice it's not even yet the final answer. Over here is going to be where the final answer is. But we've got something bigger than anything we've seen so far. So that's the algorithm. The idea is to keep track of what is the largest number we've seen so far. If we're always keeping track of the largest number we've seen so far, when we get to the end, we'll have found the largest number. Same for the smallest. Okay, so now step to the next item. We're going to do item 6. Item 6 is not going to do any updates. Okay, now go to item 7. Item 7 is going to update the largest because it's got a slightly bigger number. So now we're going to update the largest. Okay, now at this point, we've got the final answer, but we don't know that. Now, this is the difference between computers and humans. You and I can look at this and we know that the largest number is 47 and the smallest number is 12. But this algorithm, this code doesn't know that. It has to go through all the way to the end of the array. And it has no way of knowing, because it can't look ahead like we have, maybe the biggest number's over here, maybe the smallest number's over here. Notice that this number is pretty small. It's only one bigger than this. So, the algorithm has to walk all the way to the end of the array. Even when it has found the final answer, it doesn't know that, okay? And sometimes when you write algorithms, if you're real clever, you might be able to think of a way to make an algorithm not have to go all the way to the end. But for finding the max and min, there's really no shortcut here. You just have to go all the way to the end of the array to know for sure you found the max and the min. Okay, so now we're going to go to item 8. Item 8 doesn't do an update. Now go to item 9. Item 9 doesn't do an update. Okay, now we do the increment to 10, but now we have to do the compare. See, that just did the increment. Now we're going to do the comparison. The comparison 10 is not strictly less than 10, so we're done with the loops. And now we can just print our results. Okay, now it's going to print out the answer that the largest number is 47 and the smallest number is 12. Okay. All right. So that's actually a surprisingly useful example. Finding the max and min in an array of numbers is something that programmers do constantly. There's actually library functions. This is simple to write, but it's actually built into the Java language. You don't even have to write these loops. If you wanted to find the max or min of an array, we'll see later that Java actually has written it for us. But it's real important that we know how to do it because it's one of the classic examples of a simple algorithm. Okay, so it's real good to think through the steps that this does, because it's such a common programming-like idea that you make a guess. I could have made the guess anything I wanted to. For example, suppose I did this. Can anybody tell me what's there? This is not a good idea. Okay, now that'll work. I'll get the right answer. Unless I still get the right answer. Okay, now there's two little problems with this. I changed this from 0 to 5. Can anybody see? I actually have a bug. I won't always get the right answer. What's my bug? I've introduced a bug in the program. Even though I think this should work, there's actually, and it does work sometimes, I've introduced a bug, and after I fix the bug, then I still have a little bit of a problem. Does anybody see the bug I've introduced?
Well, the problem is if it's the largest or smallest has index 0, since that's not in the loop.
Yeah,
it won't always be
remember,
right.
I had skipped over 0 because I started this guy as 0. And then when I say, oh, let me try putting 5 here, well, now I'm not checking 0 anymore. So if the largest is at 0, I really need to make that go back to 0 now. Okay, when this one is 0, I don't need to do 0 over again, so I can skip it. But if I'm going to use some other item here, I better go back and make sure I'm checking 0. Okay, so that fixes the bug. Now, what's something that's not great about this? What else is wrong? It's kind of a bug. It's in a way it's a bug, but not always. What's a little bit bad about fixing this number at 5?
If the array has less than 5
Yeah,
values.
right. Yeah. What if somebody went up here and changed this to 5? Okay. So visualize execution. Start running the program. Oops, I blew up. Why did I blow up? See, I blew up. My program died at line 17. Why did it die on line 17?
Because there's no value stored at index 5.
Yeah, see, that I made the array size 5. The indices go up to 4. There is no 5th item. Okay, so that was, picking a specific location here makes me worry about the size. If I know my array is never smaller than size 5, this would be okay. Here's one thing I could do that would be bug free. What am I doing here? This is now bug free, and no problem. What's my guess at the beginning?
The last number.
Yeah, just use the last number in the array. Yeah, that just makes it harder for people to read. This would be a dumb thing to do, only from the point of view that why make people have to think that much harder? That what you're doing is you're picking there's my array. Okay, let me initialize. Okay, there's my array. I've initialized, it's only length 5. And then I'm going to pick the last two numbers. I'm going to pick the last number as the guesses, not the first number, but the last number. Okay, right? Now, that's safe because if the array has whatever the array's length is, this is picking the last number in the array. So it's like picking 0 as the starting. It's like putting 0 here. It's just as safe as putting. It's just as safe as putting 0 there. Okay, because if I want to, I can even do something weird like this. Pick the last element of that array and pick the first element of this array. Okay, notice that the algorithm doesn't care really what you started with as your initial guess, as long as your initial guess came from inside the array. Okay, there's filling up the array. Okay, there the array is filled up. Now I'll make my largest guess the last number in the array. And I'll make my smallest guess the first number in the array. Does anybody see something kind of quirky in this example?
Oh, that's actually correct for the array.
Yeah, in this example, the first number was the smallest and the last number was the largest. So I've actually got the answer already in the guesses. And so as I iterate through here, they'll never update the guesses. Okay, now, so the algorithm is, the algorithm really is saying, start with some guesses. And the algorithm doesn't really care how you start with guesses. Start with some guesses. Okay, now an easy way to guess is to pick a number from the array, pick a number from the array. You could pick the first number, you could pick the last number. If you try to pick the second number, that's dangerous because the array may not have a second number. But picking the first and last number always works because we're assuming that the array can be empty. So even this is a little bit dangerous. Okay, and it is possible for an array to be empty. And the textbook doesn't point that out. Let me show you what that would look like. See? I created an empty array. A lot of textbooks don't even ever mention this. And unfortunately, it's real. Let's go back a minute. Let me show you three different things. Int array A1 equal new int 0. Let's just look real quickly at the code generated by this. Let's look at what picture we get here. I clicked on the wrong button. Notice that an array of length 0 is in an empty array. Okay, so, and then that's the same thing as saying an array with no numbers in it. Okay, so there's two ways of, Java lets you write it two different ways. You could say an array with length 0, which means it has no numbers in it, or you can say an array with no numbers in it. Now, unfortunately, this one's different. And a lot of people call that empty array, and that's not an empty array. There is no array there. You have an array reference variable, but there is no array object. And this is really dangerous. There are many people who make the mistake of thinking that A3 is an empty array. Okay, but on the other hand, this is what we mean by an empty array. Okay, now let me show you why those things are really different. Let me print the A1's length. Oops. Okay, I can print out how long A1 is. And what if I try to print out A2's length and A3's length? Okay, now A1 and A2 are just two ways of writing an empty array. So their length is 0. Okay, but A3, watch what happens when I get to A3. I mean, think about it. What might you think happens there? We saw the picture a minute ago. This is an array object, but its length is it's array object that doesn't hold any numbers. So we call it an empty array. Okay. It is an array object. It doesn't hold any numbers, so the length is 0. And this is just the same thing. Can anybody see what's kind of going to go wrong here?
There's nothing to find the length of.
Yeah, and what's Java going to do actually?
Give an error.
Yeah, it's going to give an error. It's going to say there is no array 3. There's a reference variable A3, but it doesn't point at anything. So there's no array object to ask the length of. So it's going to give a error message. There's the empty array. There's the empty array. There's the null reference. Array reference variable that is not pointing at anything. 0 for the length of A1, 0 for the length of A2, and a nice error message for the length of A3. Null pointer exception. Here's where the word point, this is as far as I know, the only place in the Java language where they use the word pointer. Pointer is a very big part of the C++ language. And the Java language avoided using the word pointer, except somebody goofed. Somebody let this slip through. It should have said null reference exception, because Java is very adamant about using the word reference. These arrows are called references. C++ calls them pointer. And Java language tried to make a big deal of there are no pointers in the Java language. There's references. The one place they goofed up is somebody called this null pointer exception, and it just slipped through. It should have been null reference exception. Okay, and I think, as far as I remember, it's the only place in the whole Java language where they let the word pointer slip in. Okay, all right. So it's not valid to ask a null reference anything. See, there is no object over here. You're not asking this guy a question. See, notice you don't read this as asking A2 a question. You're asking this thing a question. So you're saying, A2, go to your object and then ask how long it is. A1, go to your object and ask how long is it. This is saying, A3, go to your object. Oh, there is no object. So though I can't compute the length because there is no object. Okay, this is real subtle and it's real important, the difference between these. This is empty array. Now our program, the way we've written it is actually a little bit of a mistake. Our program only finds the max and min of non-empty arrays. What would we, and this is actually an important issue, what would be the max and min of an empty array? Okay. You might ask, that's actually a very strange question to ask. What's the maximum of that array? What's the minimum of that array? Now, let me show you something. Here's a library that's built into Java. It's like the string library, but it's an arrays library. Okay. And it has oops, I skipped over it. Oh, I thought it was in here. Oh, I forgot. I'm sorry. I thought it was in this library. I thought there was a max and a min for arrays. Oh, it's not in this library. I forgot where it is now. Maybe it's in. It's hard to keep track of some of this stuff. Oh, that's the packet. Let's see. No, I'm not even finding it. Okay, I don't remember where it is now. But the answer to that question, yeah, what's the max? Our program won't work on this. Where's our program going to blow up if we try to give it this, an empty array? Actually, let's go ahead and step through it. Okay, that one blows up, so let's get rid of it. Okay, here we're going to make an empty array. Okay, let's watch what happens if we try to go through here and see where it blows up. Skip over this part. Okay, now there's our empty array of random numbers. Okay, is it okay? Let's fill it with random numbers. Okay, this is our empty array. This is not going to cause a problem. Okay, because this is going to loop. Now watch the loop. I equals 0. There's I equals 0. So we just did the initialize part. Now we do the test part. What happens here?
It doesn't execute because 0 isn't less than the length, which is 0.
It doesn't try to fill the empty array, which is okay. It does the right thing. It's just going to skip over there. It does not try to fill an empty array. So that's why this loop is written very carefully. This loop works on an empty array. But what happens now?
It's an error because you can't, there's nothing at the index 0 since it's empty.
Yeah, we don't have it. We can't make a guess. Our algorithm says make a guess. Pick one of the numbers in the array as your initial guess, but there's no number to guess with. So our algorithm blows up on trying to make a guess. So we have an algorithm that finds the max and min of a non-empty array, but it doesn't work on an empty array, which is actually kind of a bad thing. Okay. later on, we're going to have to learn ways to work with, our algorithms should always be right. So if this is an algorithm that finds the max and min of an array, it should work on an empty array too. And there is a way to make that work. There is an answer for what the max of an empty array is. But you have to go look in math books. There's actually, this is an idea that comes out of math. I'm not even going to tell you the answer, but there is a valid answer to what is the maximum of an empty array and what is the minimum of an empty array, okay? And a properly written algorithm would actually handle those two as special cases. If it would have to detect if this is an empty array and then give the special answer for empty array max and give the special answer for empty array min, okay? So right now we have an algorithm that finds the max. So I can put it up here, say it find the max and min of a non-empty array. Okay, and it's actually, that's what we've done. We've only found the max and min of a non-empty array, not an empty array. Okay. So, and the sticky point is here. For an empty array, we don't have anything to make as our initial guesses. So we'd have to do, if we wanted to handle the empty array case special, we'd have to change this part here. If the array is not empty, there's always an item at the beginning and there's always an item at the end. So we can use those as our guess, and then we could step through the array, okay, and compare the guess to all the elements in the array. Okay, all right. So this right now we're starting to see how tricky in the long run some of these things can be. You know, you have an algorithm that looks straightforward, find the max and min of an array, and then it is correct, but then you get thrown for a loop and you get pointed out, well, the Java lets you have empty arrays. For example, C and C++ don't let you have empty arrays. The C language does not have empty arrays like Java does. You can't do that in the C language. Python and JavaScript allow them, but C, and I don't remember, C does not allow them. C++ probably does allow them. It depends on how you declare them, because C++ is includes the C language. So part of C++ does not allow empty arrays, and part of C++ does allow empty arrays. It depends on how you create them, because C++ is complicated. Okay, but the Java language most languages nowadays do allow empty arrays, but C is a little bit of an older language and it doesn't allow them. It does not have a way to deal with the idea of an empty array. Okay, so every array has to have at least one item in it in the C language. Okay. Okay. So in Java, you can do this thing here of, now that's, again, be careful. That's real different than saying there's no array there. It's very important to keep track the difference between array. Now they probably should have drawn this a little bit differently, but they wrote out the words empty array. An array with no cells. Okay, it is an array, but there's no cells in the array. There's zero, the length of the array is 0. There's no items in the array. And this, which means that there's a reference variable, but there's no array. The reference variable is not pointing at an array object. So just like, oh, this line does 3 things. Okay, this line does 3 things. How many things does this line do?
1.
What would that be?
It just declares the variable.
But it does something else. It does 2 things. It declares the variable and
Assigns it?
yeah, assigns it what?
No.
No. So it puts the word null in there. See, in the C language, you can create a variable without putting anything in it, and then what's in it is a random number. So it's important that this does 2 things. It creates a variable and puts something in it. Later on, you'll learn that in a language like C, you can create a variable, and that's all, just create a variable. And then since you didn't put anything in it, the variable has a random number in it. Whatever was like there in the, you just get whatever was in memory from previous uses of the computer. Okay, so in a language like C, you can actually create a variable and not put something in it, but then you just get, we say you get garbage in it. You get a random number. This puts something specific in the variable. It puts the null in there. Java won't, in Java, you have to always put something in a variable. You can't leave a variable with just garbage, random, something random in it. Okay, now actually you can, let's see. What if I delete this? Watch what happens here if I delete this. Okay, so that just creates the variable.
Now, I got one quick question, Professor. So I see that you have two different empty arrays, and I think you probably covered this already, but I missed it. What would be the difference between those two?
Just the way you write them.
So, okay, just the way you write them. So
Yeah.
you can use either one of those for any occasion.
Yeah, if this is one way to say empty array, and this is the other way to say empty array. There's just two ways of writing them. These two guys are not different. They are exactly the same. So that's a good question. It's two ways to write empty array, not two different kinds of empty array. Two ways to write it, not two kinds. Okay. All right. Now, watch what happened when I did this. Does anybody see what happened?
You declared it, but you never assigned it. So.
And what did the Java visualizer do?
Skipped over it.
Skipped over it. It doesn't even treat it as, essentially it's ignoring it because you're not supposed to create a variable without a value. It compiles and it's just kind of quirky. I mean, the Java visualizer just totally ignored it because it didn't really do anything. Yeah, you created a variable, you didn't put anything in it. From the point of view of the visualizer, the variable's not even there. It's a little bit quirky. Java is, what Java's doing in a case like this is a little bit hard to explain, but it shows you that you really are supposed to put a value in the variable. Java doesn't like it when you create a variable without a value. Okay, so here the visualizer just skipped right over it. It ignored it. Okay, right? So the Java visualizer just said, well, if you create a variable and put nothing in it, it's as if the variable doesn't exist yet. So now here's. Okay. Now watch what happens now. Okay, it's going to skip over line 13. Now notice A3 didn't show up, but A3 really is there, but the visualizer won't show it to us until we give it a value. So the visualizer was actually choosing not to show it to us until it had a value. It essentially, from the point of view of the visualizer, the variable doesn't exist until it's been given a value. It just doesn't exist until it has a value. Okay, and it didn't matter if I made that. I could have even made this an array. The visualizer will skip over the declaration if it doesn't give it a value. Okay, it's going to skip over line 13. Okay, but A3 really is there, and as soon as I give it a value, now it says, okay, I'll show you A3. But it won't let me see it until I give it a value. Okay, because a variable doesn't exist until it, in the way Java works, a variable doesn't exist until it's been given a value. Unlike the C and C++ language, where this would create the variable and there would be essentially junk, a random number, just what people refer to as garbage value. There would just be some value in there, but you don't know what it is. And every time you ran the program, this thing would start up with some other value, a different value every time you started the program. That's actually a source of many bugs in C++. Doing this causes bugs in C++. And if you're a C++ programmer and you write a line like that, your boss will flag it and say, no, we never do that. We always give a variable of that, just like Java forces you to. In C++, you're not forced to, but your company will force you to give a value to every variable as soon as you declare it, because otherwise you get bugs, very strange bugs. Okay. All right. So now remember, we've got an algorithm that finds the max and min in an array. It's a nice algorithm, very famous algorithm, gets used all the time. Make a guess and then update the guess. But it doesn't work for an array of size 0. When the array doesn't have anything in it, we can't start with a guess. So we really should learn how to fix this algorithm, but the idea behind fixing it's not worth a while right now. You'll learn it later on. Okay, but it is worth knowing that there is the idea of an empty array, and our algorithm doesn't work on it. Okay, our algorithm's got a problem with the empty array. And we know where the problem is. The problem is the initial guess. Since there's no value in the array to make as the guess, there's no initial guess. We can't read out of the array an initial guess. Okay? All right. Now let's look at another algorithm, another traversal algorithm. Okay? Okay? This one searches the array for a particular number. Okay, the idea is to somebody, what we're going to do is I'll make it smaller again because the visualizer is not going to like an array of 100. So let's make an array of 10. Okay, all right, and then wow, I don't remember why I wrote that this way. This is another way to write a random number generator, a more complicated way. This is supposed to generate random numbers between 1 and 200. Let me just go back to, I don't remember why I wrote that the more complicated way. Sometimes there's a little bit of advantage to writing things like that, but let's not use the more complicated way. So see, the simple way is just to say random next int, okay, between 1 and 100. So this is a random integer between 0 and 99, okay? So over here, I was using a different function. I was using this thing, see, it just says random here, okay? Oh, and I'm using I remember why. That's a different random number generator. Java's got 2 random number generators built into it. And see, this one, see, I import the random number generator. Notice this one, there's no importing a random number generator. It's using a random number generator built into the math class. But that random number generator works a little bit differently than the one that's in the util package. Okay, so there's this random number generator, which is easier to use, and there's this random number generator that's harder to use, and I did it one way in one program and one way in another program. What this does, this is more tricky. That generates a random decimal number between 0 and 1. Okay, so that random number generator generates a random decimal number between 0 and 1. Then you multiply it by 200, you've got a random number between 0 and 200. Okay, and then you add 1 to it, but then you have to convert it back to an int. So you have to do a whole bunch of playing around, because what it does is it starts off by giving you a random decimal number between 0 and 1. So let's not do it that way. Let's just go back to the easier way. Now, the easier way means I have to import this guy. And then here's the complicated way. The simple way was, so you can let you compare them. Here's going to be the simpler way. It's just in this case, I'm doing between 1 and 200. Okay. Okay. So the easy way. This was added to Java later on. This is the original hard way. I mean, this was in Java from the very beginning. And then later on, they added this one to make things a little bit easier. So sometimes I still had programs that used the older, harder way. You can see it's way more complicated to get a random number between 1 and 2, in this case, between 1 and 200. Okay, so there's the harder way. You can see it's there, but we're not going to use it. We'll go ahead and stick with the easier way. Okay, so fill the array with random numbers between 1 and 200. Okay, Now we're going to search for the number 100. Did we get the number 100? Okay. And actually what I'm going to do is I'm going to search a bunch of different ways. Search using a while loop, search using a for loop, do it again using a for loop, but a different way. So we're going to do it 3 different ways. So we're going to see 3 ways of searching for this number. And one of the ways will show us something that's a little bit interesting that we haven't talked about yet. Okay. So what are you going to do? You're looking for the number 100. So you have to go through the whole array. Well, actually, watch. I wrote this in a kind of tricky way. Normally what you would do, let me do a case 0. One is better than 0. So here's a 0. Search the array using a while loop. And what you're going to do is step through the whole array. So we started, I'm writing this with a while loop. So I'm going to say start at 0, go up to the end of the array. For each entry of the array, well, you have to ask, is the element we're looking at is it the number we're looking for? What do we do if we found the number we're looking for? Okay. Okay. Well, what we want to do is remember where it is. Okay. So I need to remember where it is. So what I'm going to do is I'm going to create another variable called I. That's going to be remember where. Actually, let me give it a better name, where. Okay. Okay. If I found the number that I'm looking for, then I say where equals J. And then I increment to the next slot. So I'm going to walk through the whole array, and I'm going to keep looking for this number N. Okay. And if I find the number N, I update where it is. Now, if I find it multiple times, what's where going to be ending up? Yeah. Let's see. Let me do one thing here. Oh, let's go back and think a little bit. How do you suppose you have to find a number in an array? Let me just draw a picture. This is actually a little bit trickier than it might seem. So here's a way to describe an array. Here's a entry in the array. Here's another entry in the array. Okay. So here's an array with 1, 2, 3, 4, 5, 6 slots. Okay. And let's put the number, say, 1 in the first slot. Let's see. So 1 there, say 5 there, and say 2 there, and 9 there, and 0 there, and 4 there. Okay, so there's an array with numbers 1, 5, 2, 9, 0, 4. So now the idea is that this is index 0, index 1, index 2, index 3, index 4, and index 5. Okay, so these are the indexes. And this is the entries. Okay, so we have an array with the indexes 0 through 5, and here's the entries. Now let's look for the number 4. What should the answer be?
Five.
Yeah, search for 5. So you would give the index of where it is. Okay. Search for 4. The answer is index 5. Okay. What if you search for what if you search for 1?
Index 0.
Yeah, the index is 0. Okay. And I'll just do another example. What if you search for 0?
Index 4.
That's index 4. What if you search for 3?
It's -1
Well, why?
because there's no 3.
Yeah. Now, where have you seen that before?
When it, what was it called?
You've seen that before. That's a nice trick,
Yeah.
So now why, we can't give an answer like 0 because 0 is a valid index. So the idea is it's not found. So we give an answer that indicates not found, but we've seen that before. Does anybody remember who else did that? Where
It
did we see?
was the index of,
Yeah, in string, the string class. When you ask for the index of a character in a string and the character doesn't exist, you get back -1. Okay. So I should give, my answer can be either -1 for not found or an index. Now go back to my code here. What should I initialize where to? Where is going to be where the answer is in the array?
-1.
Why?
Because we're gonna assume it's not there to start.
Yeah, and then we update we make an initial guess. We guess that it's not there. And then we guess that n is not in the array. But then we update our guess as we go along. Okay. So now we go through the whole array. If the random number is somewhere, if we find our number there, we update our guess to where we found it. Okay. Okay. And then when we're done, we can print the index of n is where? Okay, so the index of the number we're looking for is there. Okay, and if I want, I can put punctuation at the end. I could even do this. Okay, make it a sentence. The index of n is where? Okay, now this could be -1, which would mean not found. Okay, now let's go back to these examples over here. Suppose I search for 1. Okay. I'll see. Let me change this. Okay, now let's go back. When I get to this line, what could be the answer for 1? Search for 1. What's interesting now?
There's 2 1s.
There's 2 1s, so there's 2 possible answers. There's the first occurrence, there's the last occurrence. what does index of give you? And remember, when you do index of, which is a search, it gives you the index. And what does it get? If there's multiple occurrences, what does it give you?
Doesn't it just give you the first instance of it?
Yeah. And there's actually a separate function, which did what?
Last
give you-
index?
Yeah, there was even a special function for last index of. What about the middle indexes? If the thing was in there 3 times, what about the middle one? Do you remember what we said about that?
I don't think there was a function for
Yeah,
that. Was
There isn't. Yeah, it'll find the index of finds the first one. Last index of finds the last occurrence. And if you want the occurrences in the middle, you have to do a lot of you have to do substrings, and you have to do a lot of work because there is no function that'll find middle occurrences, only the first and last. What does my little algorithm do here?
it creates an array of all the indexes?
No, I only have one answer. That would be a nice question. See, that would be a good answer in the future. Like, what if you created an array of all the answers? We'll do that one later. That's a little bit trickier of a problem. But what does my algorithm do? It only has one answer, the int where.
It prints out the last occurrence
Now, why is that?
because that's what value where will be at the end of the while loop.
Well, okay, because well, what's happening when it finds an occurrence, it always updates, right? It doesn't stop. Now, how can I change that to somehow do first occurrence? Why? See, notice this one gives me the last occurrence because there's no way to stop this loop. The loop goes all the way up to the end. So every time it finds an occurrence, it updates where. So where ends up being where the last occurrence is. What would I want to do to make it so that I got the first occurrence? Think if you were doing it yourself. If you were stepping through this array, looking for 1, you could go all the way through the array and keep track of if you found 1. So you found 1 here, 0, found 1 here, 2. So then you didn't find it again, so you report 2, because that's the last time you saw 1. But what else could you do if you're searching through this array? And don't think of programming, just you. You find 1. You're told to go find a 1. See, you're told to search for a 1. You found a 1. What could you do?
Could you just do like a regular if statement?
No, no, no. What would you do? Somebody told you to go look for a 1. Yeah. So you're looking in these boxes. Okay. You could look through the first box, the second box, the third box, and every time you find a 1, you say, "Oh, I found," and you can remember the last box you found the 1 in. Okay. So that's our algorithm. You look in a box, you look in a box, you look in a box. But think about it. What else could you do? Instead of constantly keep looking through boxes, you found a 1. What could you do?
Just stop.
Stop. Yeah. You found a 1. You were told to find a 1. You found a 1. So you could just stop the search when you found something. Okay. Now that's what we would like our code to be able to do also. Like this one continues the search even after it's found something. That's what this one does. This one stops the search when it's found something. And it does it with a little bit of extra logic here. Okay. This one stops the search when it's found something. And then J would be the index of where it stopped the search. Okay. Okay, we run out of time. We'll start with these on Wednesday. This search algorithm is actually trickier than it might seem because of like these issues like with index of. Should you report the first index? Should you report the last index? What do you do when you can't find the number? So we've got several issues to deal with. Which, when you're searching for something, do you report the first thing you found or the last thing you found or all of the things you found? How do you signal the fact that you couldn't find the number you were looking for? So report first, report last, possibly report all of them, and what happens when you don't find any entries? So the search algorithm is a little bit tricky for that reason. They're all now, so that ends up meaning we have to do different kinds of array traversals. This one traverses the whole array. This one stops the traversal as soon as it found something. So it stops the traversal using this AND, because it's checking for two things. If it finds the number, if it keeps traversing if it does not find the number. See, while I have not found the number, keep traversing. But if I do find the number, that makes this thing false, so you stop looping. So there's a little bit of interesting logic here. We'll start with that on Wednesday. Okay, so we'll quit here. I'll put these examples up on the course website. I'll put the examples we've done so far up on the website, and we'll pick up with this on Wednesday, because this is actually, there's a lot of ideas here. Even though it's a simple algorithm, there's a fair amount of ideas involved here. And if you have any questions, oh, and look for your homework, look for your exam 1 score either later today, this afternoon or this evening, okay? All right, so, and if you have any kind of questions, let me know. And after I get the exams graded, I'll put up another programming assignment. You're due for another programming assignment, but right now I'm spending all the time grading. So as soon as the grading is done, I'll be able to put up another programming assignment for you. Okay, so we'll go ahead and I'll stop sharing and see you on Wednesday, okay? And send me emails if you have any questions. Bye.